Hello everyone. Today I'm going to go over a binary tree question in the medium category that I solved earlier today. And so yeah, let's read it. So essentially you're given a matrix of arrays of integers and you have three values. So you have the parent, that's the 0th index, the child as the first index, and Boolean 1 0 kind of value that indicates whether it's the parent or the child as the second index value. And so you simply want to, given this list, based on these rules, you want to reconstruct the tree and return its root. And so, yeah, there's a pretty easy way to do this. I think is just to use a hash map. And you can, in Python, you have a convenient default dig list. And if you make some observations, you'll notice that we can simply just iterate over, let's call this myD. You can iterate over the input list, and you can also simply just put the first and the second index values as the value and the 0th index as the key. D0 dot append D1 and D2. And this is just going to make it easier to reconstruct the tree later. And yeah, so now let's just print this out to see what it looks like. So as you can see, we got the children of 20, we got the children of 50, and the children of 80. Now we simply have to find the root to start the traversal because they don't tell us what the root is here. So if you make another observation, you'll notice that the root node is simply the value, or because we don't care about this index, it's the value that doesn't appear as any of the inside of any 0th index of the values of each key. So to find that, let's just say create an array called notRoot, and let's create another array called allNodes, and let's append into this array the 0th index of each sublist, right? Or the first index, actually, because so we want 15, 17, and 20. If you just observe this, you can see we're going to append D0 and D1. We don't care about D2, obviously, because that's just the Boolean flag. Let's print all nodes out to see what it looks like. Okay, so now we can make that observation. Why is this showing here? Because we're trying to get 50. Oh, yeah, let's not append the keys because that's not what we're looking for. We're just looking for everything that's in the value. So as you can see, 50 is not here, and that's why it's going to be the root. If you observe the other test cases, you'll notice that it's consistent as well. 1 is not in here, and 1 is not in the 0th index position of any sublist. Cool, so now we have our root. We're going to call this root value and set it to 0. And now we're going to iterate over whatever we just said. So for each node, if it's, well, okay, all nodes are all nodes, right? And then notRoot dot append D1. Print all nodes, all notRoot. See what it looks like. Okay, as you can see, there's one that's 50 is not in here. Okay, so for n in notRoot, if n not in all nodes, then we can say that the root value is equal to n. Then we can break it because there's only one root, right? So let's print the root value to see what it looks like. Okay, that's not what I wanted. All nodes, if n in all nodes, not root. There we go. Yep, other way around. So now we got the root. Now we can just reconstruct the tree. The easiest way to do this, in my opinion, is just to use a level order traversal. The same way, a BFS style, going through level by level and setting the left and the right children. So, okay. The reason I call this root value is because we actually need to return a root at the end. So this is going to hold the value, and then we can append that to the deck. And then, as usual, while the deck is not empty, we still have more nodes to process. And originally when I solved this, I thought that we had to use the leaves, but we don't really care about that because the leaves, if you make an observation again, is not going to be the key of any of these. So we're fine in that regard. It's not going to cause an error. And we're just going to go through each level of the doubly ended queue and pop from the beginning. And if the node exists, then we can simply say, so if, now we just want to get the children of it, right? So current equals d current print current. See what it looks like. Okay. Dot value, and then let's print d current. Oh, my d current. This is not, there we go. So 20 and 80 other children. And then if, so, okay, so current list equals to my d current. Iterate through that. If a0, because we're looking at, or a1, sorry, looking at that is equal to 1, then the instructions say that it's a left child. So current dot left, because we know this is not none, is equal to tree node of a 0, because if you can see 0 is the actual node value. And if it's not the case, then it's going to be 0. Then cur dot right equals tree node of a 0. Yep, because this is the current list that we're iterating over. And then at the end, I think we can just return the root. And because we did everything else, equals comparison. Okay, so that was not it. Let's see. The problem is because we didn't append the children to the deck to finish off the traversal. And now that should be fine. And there you go. So pretty straightforward. It looks more confusing than it really is, but just make sure to find, you really just have to follow the instructions and find the root node. So yeah, I hope this is helpful to you guys, and thank you for watching.